right, picture this, a biological factory that doesn't just survive in the most punishing, hyper-arid environments on Earth, but literally dominates them. Welcome to today's Explainer. We are going to unpack the absolute marvel of natural engineering that is the kikar tree. You might also know it as Babul. Honestly, this plant is just a masterclass in survival. We're going to deconstruct it from its molecular taxonomy all the way down to its roots. We'll look at the incredible defensive architecture and the chemical weapons it uses to stay alive. And, as you'll see, we'll also explore how humanity has harnessed these exact same defense mechanisms for everything from traditional wellness practices to massive global industries. So here is our roadmap for today. We'll start with the Vachellia botanical identity, move into its evolutionary armor, explore its chemical defenses, and then dive into traditional dental and gut health, restorative gum for joints, and finally, its massive role in global trade and tanning. Okay, Section 1, the Vachellia botanical identity, and reclassifying the Egyptian thorn. Let's get right into it. Now, what is truly fascinating here is how modern molecular data forced botanists to completely rethink this tree's family tree. For the longest time, it was known globally as Acacia nilotica. The genus name Acacia comes straight from the ancient Greek root akis, which means a sharp tip or spine. And honestly, that is a very fitting name, as we'll see in a minute. The nilotica part was assigned by early European botanists who saw it growing massively along the banks of the Nile River in Egypt. But, science marches on. Recent molecular phylogenetic data proved its evolutionary history is distinct enough to warrant a total genus shift. So, while it's still sitting comfortably in the Mimosoideae subfamily of legumes, its modern, scientifically accurate name is actually Vachellia nilotica. But before we even get to the tree's physical defenses, we have to talk about its structural role. This isn't some fragile little desert shrub. Not at all. This tree grows up to 20 meters tall. It develops this incredibly deep, complex root system that acts as a structural stabilizer. Think about it. In hyper-arid subtropical zones or flood-prone riverine ecosystems, the soil is incredibly fragile. It's highly prone to severe erosion. The kikar tree steps in like nature's rebar. Picture a 20-meter living anchor locking the earth in place and stabilizing entire landscapes that would otherwise just wash or blow completely away. Moving right along to Section 2, Evolutionary Armor and Architecture, let's talk about surviving the hyper-arid threat. If you're out in the wild, maybe you're a botany or ecology student, and you want to spot this tree, you are looking for some very distinct visual markers. It's all about striking contrasts. You'll see these bright, golden yellow spherical floral heads that are super aromatic, popping against a deeply split, rugged, dark brown or pitch black bark. You'll also immediately notice these really aggressive thorns and very unique, velvety gray-green seed pods. If you learn these specific traits, you've got yourself a perfect, practical field guide for identifying the species out in its natural habitat. So, facing extreme drought and aggressive animal threats, we really have to stop and ask, how on earth does a tree loaded with nutrient-dense leaves survive in a landscape where literally every herbivore is starving for moisture and calories? Well, the evolutionary solution is brutal but incredibly effective. It's a physical defense system. Arising directly from the base of its leaves, which botanists call bipinnately compound leaves, are pairs of stark, razor-sharp, ivory-white stipular thorns. And guys, these aren't tiny little prickles. They can grow up to 8 centimeters long. They act as a menacing cage that aggressively defends those nutrient-dense leaves from hungry grazing animals. It is just a perfect example of phenotypical armor. And those physical adaptations? They extend right down to the seeds, which are housed in a structure called a moniliform lamentum. It's a fancy botanical term, but it basically means a highly specialized, elongated pod that tightly pinches inward between every single individual seed. It doesn't have a smooth casing at all. It looks exactly like a string of tightly bound prayer beads. Plus, the entire outer pod is covered in this dense, velvety gray down. This constricted shape and unique texture are absolutely vital for seed dispersal in arid zones, and they make for a foolproof visual marker if you're trying to identify the tree. All right, Section 3, Chemical Defenses and Astringency. Time to look at the phytochemical complex. Going beneath the surface, we transition from physical thorns to some seriously powerful chemical defenses. When that deeply split bark is breached, the tree doesn't just sit there, it fights back, chemically. The big player here is tannins. These are high molecular weight, condensed polyphenols. Now, to put that into plain English, when tannins touch organic tissue, they instantly cross-link surface proteins. This rapid cross-linking precipitates cellular membranes, meaning it causes tissues to immediately tighten, constrict, and seal. It is a wildly intense, astringent action that locks out infections and pests. What's wild is how different parts of this tree act as concentrated storage banks for entirely different chemical weapons. The bark and the pods, they are loaded with tannins and catechins, making them powerful astringent and anti-hemorrhagic agents. But then you have the dark gum that secretes from the trunk, the exudate tears. That's made of complex polysaccharides that actually act as a mucosal protective layer. And the juvenile twigs are packed with volatile oils and saponins for deep antimicrobial defense. The entire tree is basically a fully stocked botanical pharmacy. Which brings us to Section 4, Traditional Dental and Gut Health, the Unani and Ayurvedic Clinic. Now, human beings figured out how to harness these botanical weapons centuries ago. Long before you could buy synthetic commercial toothpaste, people relied on the dot and chewing ritual for daily oral health. You take a fresh, juvenile kikar twig and chew it. The wood fibers separate into a natural bristle brush, which is cool, but the real magic is the chemistry. The chewing releases those localized tannins, catechins, and volatile oils straight into the mouth. These compounds go to work mechanically killing cariogenic bacteria like Streptococcus mutans, cutting down plaque and using that incredible astringent power to rapidly constrict soft gum tissue. It literally stops periodontal bleeding in its tracks. And that exact same astringent power works wonders for gastrointestinal relief, too. In traditional Unani medicine, practitioners use dried strips of the bark, traded locally as Chaal Kikar. They prepare a cold decoction, which releases a massive load of tannins into the liquid. When a patient drinks this, those complex polyphenols form an instant, tight, astringent coating right over irritated intestinal walls. By mechanically binding those surface proteins, it reduces hypermotility and stops fluid secretion. It's a remarkably targeted treatment for acute diarrhea and dysentery. Next up, Section 5, Restorative Gum for Joints. Let's talk about preparing Gond Kikar. So you might be surprised to learn that, unlike the highly astringent bark, the tree's gum is actually an elite nutritional tonic. But here's the catch. You can't just eat it raw. Traditional healers use a really specific culinary transformation. First, you harvest the raw gum exudate tears, known as Gond Kikar or Gond Babul. Then, you fry that raw gum in pure lipids. When the heat hits it, the dense gum swells and pops into these light, crisp bubbles. Finally, those bubbles are integrated into premium winter restorative snacks, like ladu. Culturally and clinically, this is consumed to support musculoskeletal vitality. We're talking about strengthening spinal column density and deeply lubricating worn joint matrices. It's fascinating. And finally, Section 6, Global Trade and Tanning, from local markets to global mills. Now let's zoom out and look at the macroeconomics, because this single tree supports a massive dual-market global economy. It's a tale of two industries. Over in the subcontinent, places like Pakistan and India, the focus is really on traditional botanical retail. They harvest twigs, pods, and pure Gond Babul to supply bustling, historic herbal pansar markets, like Lahore's famous Akbari Mandi. But if you look at the African savanna and the Nile Basin, the trade is heavily industrial. There, they focus on commercial-scale bulk harvesting of the bark to supply enormous international leather tanning hubs. That raw African bark is transformed into commercial tanning liquors on an industrial scale. Think about it. The very same tannins that cross-link proteins to stop a bleeding tooth are extracted to preserve animal hides. Massive industrial crushing mills process thousands of tons of raw kikar bark. They extract natural tannin liquors to treat and preserve premium leather. And today, this is incredibly valuable because it's a sustainable, eco-friendly process that totally bypasses the need for harsh synthetic chromium chemicals. But it doesn't stop at the bark and the gum. The timber itself drives a huge agroforestry economy. Kikar wood has this extreme structural density and a beautiful, deep, rich grain. And crucially, it possesses a complete natural immunity to termite attacks. You just don't have to worry about pests destroying it. Because of this, it's used to forge heavy-duty agricultural tools, it's crafted into highly durable rustic furniture, and its density makes it absolutely perfect for burning long and hot as high-efficiency industrial charcoal. So I want to leave you with this final provocative thought. Consider the incredible, untapped biological engineering silently surviving right now in the world's harshest environments. If a single tree, armed with ivory thorns and velvety moniliform pods, can literally fortify a collapsing riverbank, reverse a bleeding tooth through its chemical astringents, and preserve natural leather for the global market, What other profound biological factories are hiding out there in our most arid landscapes, just waiting to be fully understood? Thanks for joining me on today's Explainer, and keep questioning the natural world around you.